The year 1919 marked a pivotal moment in aviation history as the world emerged from the devastation of the Great War with unprecedented technological advances and a transformed understanding of flight's potential. In the workshops of Dessau, Germany, Hugo Junkers and his team of engineers were quietly revolutionizing commercial aviation with a design that would fundamentally alter how passengers and cargo moved across continents. The Junkers F-13, conceived in the shadow of Germany's military defeat, represented a radical departure from the fabric-covered biplanes that had dominated wartime skies. Junkers, already renowned for his pioneering work with all-metal aircraft construction during the conflict, recognized that the future of aviation lay not in military applications alone, but in connecting distant cities and nations through reliable passenger service. The strategic need for such an aircraft emerged from the post-war economic landscape, where traditional transportation networks had been severely disrupted and new international boundaries demanded innovative solutions for trade and communication. Unlike the fragile wooden structures typical of early aircraft, Junkers envisioned a machine built entirely of metal, capable of withstanding the rigors of commercial operation while offering unprecedented safety and reliability to paying passengers. Otto Reuter, Junkers' chief designer, worked alongside a team of engineers who had gained invaluable experience developing the revolutionary J-I ground attack aircraft during the war. Their collective expertise in corrugated aluminum construction, cantilever wing design, and enclosed cabin architecture would prove essential in creating an aircraft that could operate profitably in peacetime conditions. The F-13's conceptual blueprint emerged from careful analysis of passenger requirements and operational economics, considerations largely ignored during wartime aircraft development. The design featured a low-wing cantilever monoplane configuration, eliminating the external bracing wires that created drag and maintenance complications in contemporary aircraft. The corrugated aluminum skin, a Junkers trademark, provided exceptional structural strength while remaining relatively lightweight. Most significantly, the enclosed passenger cabin represented a revolutionary concept, protecting travelers from wind, weather, and engine noise that made flight in open cockpit aircraft an ordeal rather than a convenience. The initial blueprints called for accommodation of 4 passengers in comfortable wicker seats, with large windows providing unprecedented visibility of the landscape below. Development challenges emerged immediately as Junkers confronted the realities of Germany's post-war restrictions and economic limitations. The Treaty of Versailles severely constrained German aircraft production, forcing Junkers to navigate complex legal and political obstacles while maintaining the technical integrity of his design. Material shortages and financial constraints required innovative engineering solutions, including the development of new aluminum alloys and manufacturing techniques that could produce reliable components despite resource limitations. The cantilever wing design, while aerodynamically superior, demanded precise calculations and testing to ensure adequate strength without external bracing. Engine selection presented another critical challenge, as reliable power plants suitable for passenger service remained scarce and expensive in the immediate post-war period. The breakthrough came through Junkers' methodical approach to structural engineering and his willingness to invest in comprehensive testing programs despite financial pressures. The corrugated aluminum construction technique, refined through wartime experience, provided the necessary strength-to-weight ratio while simplifying manufacturing processes. The enclosed cabin design required careful attention to weight distribution and center of gravity calculations, ensuring that passenger loading would not adversely affect flight characteristics. By late 1919, the fundamental design elements had been finalized, establishing the foundation for what would become the world's first successful all-metal passenger airliner. The prototype F-13, designated D-335, made its maiden flight on June 25, 1919, from Junkers' facility at Dessau, with test pilot Emil Mons at the controls. The initial flight revealed the aircraft's inherently stable flight characteristics and smooth handling qualities, validating the engineering team's calculations and design philosophy. Unlike the temperamental military aircraft of the Great War, the F-13 demonstrated predictable behavior across its flight envelope, inspiring confidence among pilots who would later operate the type in commercial service. The prototype's performance exceeded expectations, achieving a cruising speed of approximately 140 kilometers per hour while carrying its full complement of passengers and baggage. Early test flights revealed several areas requiring refinement, particularly regarding engine cooling and cabin ventilation systems. The BMW 3A engine, initially selected for its reliability and power output, generated excessive heat that affected both pilot comfort and passenger cabin temperature. Engineering solutions included redesigned cooling air ducting and improved exhaust routing that eliminated hot spots while maintaining aerodynamic efficiency. The enclosed cabin, while revolutionary in concept, required extensive development of heating and ventilation systems to ensure passenger comfort across varying altitude and weather conditions. Test pilots reported excellent visibility from the cockpit and praised the aircraft's forgiving stall characteristics, crucial factors for commercial operation. Structural testing revealed the superiority of the all-metal construction, as the prototype withstood stress loads far exceeding those experienced by contemporary wooden aircraft. The corrugated aluminum skin distributed loads evenly across the fuselage structure, eliminating the weak points common in fabric-covered designs. Ground vibration tests and structural load analysis confirmed that the F-13 could withstand the repeated stresses of commercial operation, including rough field landings and frequent passenger loading cycles. The cantilever wing design proved particularly robust, maintaining structural integrity even under severe turbulence conditions that would have damaged braced configurations. The transition from prototype to production required substantial modifications to accommodate manufacturing efficiency and operational reliability. Production aircraft incorporated refined engine installations, improved control systems, and standardized interior configurations that could be adapted for passenger or freight service. The manufacturing process, initially dependent on handcrafted components, evolved toward systematic production methods that maintained quality while reducing costs. By early 1920, Junkers had established production capabilities sufficient to meet initial commercial orders while continuing to refine the design based on operational feedback from early customers. The F-13 entered commercial service in 1920 with Deutsche Luftreederei, marking the beginning of the modern airline era, with scheduled passenger flights between Berlin and Weimar. The aircraft's introduction represented a quantum leap in passenger aviation, offering enclosed cabin comfort previously unknown in commercial flying. Unlike the open cockpit aircraft that characterized early passenger services, F-13 travelers enjoyed protection from weather while experiencing smooth, stable flight characteristics that reduced air sickness and anxiety. The inaugural routes proved both the aircraft's technical capabilities and its commercial viability, establishing operational procedures that would influence airline development worldwide. Squadron integration proceeded smoothly as airlines recognized the F-13's operational advantages over competing aircraft designs. The enclosed cabin allowed year-round service in northern European climates, where open cockpit aircraft became impractical during winter months. Maintenance crews appreciated the aircraft's robust construction and standardized components, which reduced downtime and operational costs compared to the mixed fleets of converted military aircraft commonly used by early airlines. Pilot training programs developed around the F-13's stable flight characteristics, creating a generation of commercial aviators skilled in passenger service operations rather than military tactics. Early operational deployment revealed the aircraft's exceptional reliability in commercial service, achieving utilization rates far exceeding contemporary designs. The all-metal construction proved resistant to weather damage, eliminating the fabric replacement and wooden component repairs that plagued competing aircraft. Fuel consumption remained economical despite the enclosed cabin's added weight, allowing profitable operations on routes where other aircraft could not generate adequate revenue. Passengers responded enthusiastically to the comfortable accommodations and smooth flight experience, generating the repeat business essential for airline profitability. Reactions from pilots universally praised the F-13's handling qualities and operational reliability. Commercial pilots, many of whom had flown military aircraft during the Great War, appreciated the stable, predictable flight characteristics that reduced pilot fatigue during long routes. The enclosed cockpit protected flight crews from weather and provided excellent instrument visibility, crucial factors for the precise navigation required in commercial operations. Military leaders from various nations observed the F-13's performance with interest, recognizing its potential for transport and liaison duties that required reliability and passenger comfort over combat performance. The aircraft's early patrol missions and demonstration flights established its reputation for dependability across diverse operating conditions. Weather penetration capabilities exceeded those of open cockpit designs, allowing airlines to maintain schedules despite marginal conditions that grounded competing aircraft. Load carrying capacity proved adequate for profitable passenger service, while maintaining the performance margins necessary for safe operation from the primitive airfields of the early 1920s. The F-13's combat applications, while limited by its civilian design, demonstrated the versatility of the all-metal construction and enclosed cabin configuration during various international conflicts throughout the 1920s and 1930s. Several air forces adopted the type for transport and liaison duties, appreciating its ability to carry personnel and supplies reliably across long distances. The aircraft's robust construction allowed operations from rough airstrips and improvised landing grounds, capabilities that proved valuable during military campaigns in remote regions where conventional aircraft could not operate effectively. During the early conflicts involving F-13 aircraft, the type primarily served in support roles rather than direct combat missions. Transport versions carried military personnel, medical supplies, and critical communications across theaters where ground transportation remained unreliable or dangerous. The enclosed cabin protected cargo and passengers from small arms, fire, and weather, while the all-metal construction resisted battle damage that would have destroyed fabric-covered aircraft. Several instances of F-13s successfully completing missions despite significant structural damage demonstrated the inherent strength of the corrugated aluminum design. Air-to-air encounters remained rare, as the F-13's civilian configuration lacked armament and its performance characteristics favored transport efficiency over combat maneuvering. However, the aircraft's stable flight platform and excellent visibility made it suitable for reconnaissance missions, where observation accuracy took precedence over speed or agility. Ground operations benefited from the F-13's short field performance and reliable power plant, allowing supply missions to forward airstrips that remained inaccessible to larger transport aircraft. Tactical adaptations emerged as military operators recognized the F-13's unique capabilities within specific operational contexts. The enclosed cabin's protection allowed medical evacuation missions under conditions where open cockpit aircraft could not adequately protect wounded personnel. Communication flights utilized the cabin space for radio equipment and operators, establishing aerial communication networks across remote regions. These specialized applications demonstrated the aircraft's adaptability beyond its original passenger service design, influencing future military transport requirements and specifications. Combat losses remained minimal due to the F-13's support role rather than frontline deployment, but operational experience provided valuable feedback for structural improvements and defensive modifications. Battle damage analysis revealed the effectiveness of the all-metal construction in protecting vital components, while operational reports identified areas where additional armor or defensive systems could enhance survivability without compromising the aircraft's primary transport mission. The F-13's technological evolution encompassed numerous variants that expanded its operational capabilities while maintaining the fundamental design principles that ensured its commercial success. The basic passenger configuration spawned freight versions with reinforced cabin floors and enlarged cargo doors, meeting the growing demand for air transportation of high-value goods across distances where surface transport remained slow or unreliable. Specialized mail variants incorporated secure compartments and navigation equipment optimized for the precise scheduling required by postal services, contributing significantly to the development of international airmail networks. Engineering improvements throughout the production run addressed operational feedback while incorporating advancing technology. Engine installations evolved from the original BMW 3A to more powerful and reliable units, including the Junkers L5 and various license-built versions that improved performance and reduced maintenance requirements. Propeller efficiency improvements and revised engine cooling systems increased cruising speeds while maintaining the fuel economy essential for commercial profitability. Interior configurations adapted to customer requirements, ranging from luxury passenger appointments to utilitarian freight arrangements. International licensing arrangements allowed F-13 production in multiple countries, each adaptation reflecting local manufacturing capabilities and operational requirements. The American-built variants incorporated different engines and instruments, while Scandinavian versions included modifications for cold weather operations. These international production programs not only expanded the aircraft's global presence, but also contributed to local aviation industry development, transferring Junkers' advanced manufacturing techniques to facilities worldwide. Specialized variants emerged for specific roles that highlighted the F-13's design versatility. Float-equipped versions served remote regions accessible only by water, while ski-equipped aircraft operated in Arctic conditions where wheeled landing gear proved inadequate. High-altitude modifications included enhanced heating systems and improved engine installations for operations in mountainous terrain. Military transport variants incorporated strengthened cabin floors, enlarged doors, and basic defensive provisions while maintaining the aircraft's fundamental passenger service characteristics. The trainer versions, developed to meet the growing demand for commercial pilot education, featured dual controls and simplified systems that allowed efficient flight instruction while retaining the handling characteristics of operational aircraft. These training variants proved crucial in developing the cadre of commercial pilots necessary for expanding airline operations, establishing standardized procedures and qualifications that influenced aviation safety regulations worldwide. The Junkers F-13's global impact extended far beyond its immediate commercial success, fundamentally altering international perspectives on aviation's role in connecting distant regions and facilitating economic development. Export deliveries reached every continent, establishing the aircraft as the foundation of airline operations in countries lacking indigenous aviation manufacturing capabilities. From the remote airstrips of South America to the challenging conditions of colonial Africa, F-13s pioneered air routes that would eventually evolve into major international airline networks. Foreign air forces recognized the F-13's utility for transport and communication missions, leading to military sales that supplemented commercial orders while demonstrating the aircraft's versatility across diverse operational requirements. The Royal Air Force employed F-13s for liaison duties and VIP transport, while several South American air forces utilized the type for both military transport and nascent airline operations. These military applications provided operational feedback that influenced subsequent transport aircraft development, establishing requirements for enclosed cabins, all-metal construction, and reliable power plants that would characterize successful transport designs for decades. The F-13's influence on future aircraft design proved profound and lasting, establishing the all-metal, low-wing, enclosed cabin configuration as the standard template for passenger aircraft development. Contemporary manufacturers initially dismissed Junkers' design philosophy as unnecessarily complex and expensive, but operational experience quickly validated the advantages of metal construction and passenger protection. The cantilever wing design eliminated the drag-producing external bracing common in earlier aircraft, improving both performance and structural reliability. Design principles pioneered in the F-13 influenced major aircraft manufacturers worldwide, including Ford's Trimotor and Boeing's early passenger aircraft. The enclosed cabin concept became standard for all subsequent airliner designs, while the all-metal construction techniques spread throughout the aviation industry. Corrugated aluminum skin, while eventually superseded by smooth metal surfaces, provided the structural foundation for aircraft development during aviation's formative decades. Military doctrine evolution reflected the F-13's demonstration of reliable long-range transport capabilities, influencing Air Force requirements for strategic airlift and personnel transport aircraft. The concept of protected passenger compartments for military transport evolved directly from F-13 operational experience, establishing specifications that would characterize military transport aircraft through World War II and beyond. Cultural significance emerged as F-13 operations established aviation as a practical means of transportation rather than merely a technological curiosity. Passenger testimonials and operational reports documented aviation's transformation from adventure flying to routine commercial service, creating public confidence in air transportation that enabled airline industry growth. Museums worldwide preserve F-13 examples as representatives of aviation's transition from military applications to commercial service, recognizing the type's pivotal role in establishing modern air transportation systems. Retirement from commercial service occurred gradually as larger, faster aircraft became available, but many F-13s continued operating in specialized roles well into the 1940s. The aircraft's robust construction and reliable operation ensured extended service lives that provided excellent returns on investment for original purchasers while demonstrating the wisdom of Junkers' design philosophy. Beyond its documented commercial and military service, the F-13 contributed to numerous experimental programs and specialized applications that remained largely unknown to the general public but significantly influenced aviation development. Research institutions utilized the aircraft's stable flight characteristics and enclosed cabin for atmospheric studies and meteorological observations, collecting data that improved weather forecasting and flight safety procedures. The enclosed cabin provided an ideal platform for early radio navigation experiments, contributing to the development of instrument flying techniques that would prove crucial during World War II. Several F-13s served as testbeds for advanced power plant installations, including early experiments with supercharged engines and improved fuel systems. These research programs, while not widely publicized, provided valuable data for subsequent aircraft development and contributed to the reliability improvements that characterized aviation's rapid advancement during the interwar period. Engine manufacturers used F-13 platforms to evaluate new designs under actual operating conditions, accelerating the development of more powerful and efficient power plants. Secret projects involving F-13 aircraft included early experiments with aerial photography systems and communication relay equipment, applications that would prove significant during subsequent military conflicts. The aircraft's stable platform and enclosed cabin made it ideal for precision camera installations and radio equipment that required protection from weather and vibration. These capabilities, while not initially emphasized in commercial marketing, proved valuable for survey operations and intelligence gathering missions. Failed upgrade attempts included experiments with retractable landing gear and increased passenger capacity that would have fundamentally altered the aircraft's characteristics. While these modifications never reached production status, the engineering experience gained influenced subsequent aircraft designs and demonstrated the limitations of modifying successful designs beyond their original parameters. Test pilots involved in these experimental programs provided feedback that guided future aircraft development while highlighting the F-13's fundamental design excellence. Veterans of F-13 operations consistently praised the aircraft's reliability and forgiving flight characteristics, with many commercial pilots considering it the finest aircraft of its era. Their testimonials, recorded decades later, emphasized the confidence-inspiring qualities that made long-distance passenger service practical and profitable. These first-hand accounts provide invaluable insights into aviation's formative period and the F-13's crucial role in establishing commercial flying as a viable transportation mode.